Okay, well today we're talking chapter 1-9, patterns, equations, and graphs. Okay, this is the last section of this chapter. And the objective for today is going to be use tables, equations, graphs to describe relationships. Okay, so this is definitely involving standard A1.2.1. Okay, translate among various representations of tables, graphs, words, and equations. Okay, the first thing we have is a solution of the equation. We've talked about that before. We're going to open this up into a two-variable though now. So it's not the same vocab. It is opening up the two-variable. Two variables x, y, any ordered pair. Okay, so ordered pairs up there, x, y. In always alphabetical order when we have our variables x, y, a, b, things like that. That makes an equation true. Okay, the other vocab we have is inductive reasoning. So we're going to talk about that. That's the process of reaching a conclusion based on observed pattern. Okay, so as you go through, you're going to notice a pattern of some sort and you're going to make some sort of conclusion based on that. Okay, so problem number 1 is 310 a solution of the equation y equals 4x. So again, like we talked about, it's always x, y. Okay, alphabetical order. So that's what the ordered pair is. That's why we call it ordered. What we're going to do is we're going to plug in those values, substitute those values in. So we are going to plug in 10 for the y, and that's equal to 4 times 3, which is the x. Okay, so well 10 is 10, there's nothing to do there, but 4 times 3 is 12. Is that true? No. So this is not a solution. Okay, not a solution because 10 does not equal 12. So 310 is not a solution. Okay, so we have a little story problem here. I know we don't like those, but we need to start learning to kind of pull out the important information. But both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? So we're going to talk about 3 different styles of talking about this. The first one is to build a table. The second one's going to be writing an equation, and then we're going to draw a graph. Okay, so to build a table, we're just going to write the ages across. So Carrie, say Carrie is 1 year old. So that means Kim is what? Well, Kim is 2 years earlier, so she would have to be 3 by now. Okay, if Carrie is 2, that means Kim is going to be 4, 3, then 5. Okay, so we're just filling in a table and building a table to represent this data. Okay, 4, 6, 5, 7, okay, and there should just be that pattern. So we'll go ahead and fill this in. 6, 7, 8, 9, 10. They're all going to be about the same now. Okay, as we go through 8, 9, 10, 11, and 12. So there's building a table. It's just representing the data in the table format. Easy to gather what we were looking for. Okay, method 2 is write an equation. So I left the story problem up there at the top, but we want to write an equation. The first thing we need to do is define a variable. Okay, so I put in your notes, let x equal Carrie's age. So we're going to say here that x equals Carrie's age, and let's represent y to be Kim's. Okay. In the table, you can see that y is always 2 greater than x. So as the table that we just did, method 1, you're going to see that y is always 2 greater than x. So that means that when we represent x as an age, we're going to have to add 2 to Carrie's age there to determine what Kim's age is going to be. So if she's 1, 1 plus 2 makes 3, which would fit our table. Okay, so that's how you build an equation. You take what you know and you start from there. So we know that if Carrie is 1, we're always adding 2 to figure out what Kim's is. Okay, and we could use C and K on that. just decided to stick with x and y to start out with. Okay, so we represent that as equation. Okay, method 3 here is using a graph. So here we have a Cartesian plane. That's what this is called, a Cartesian plane. I went ahead and put Kim's age here on the y-axis, okay, and Carrie's age on the x-axis, so it fits. Okay, so I'll go ahead and fill in the x and y there. So there's those variables there. And we just want to start drawing our information as we go. So since Carrie, let's say Carrie starts off at 1 year old. Okay, actually I'll start here at 2 because that's what I put in your notes. Okay, so if we start off at 2, that would be 1 there. Okay, so if we go 1, she's going to have, Kim is going to be 1, 2, 3. There. So let's backtrack. What happens if Carrie is 0? Well, that means that Kim has to be 2. Okay, if Carrie is 2, so I'll put that in there. If Carrie is 2, then that means that Kim is 3. Okay, and if we say 3, it's going to be 4, or yeah, and then 4, we're going to keep going up. So this will be 2, 3, there's 4, 5, 6. Okay, and count by 2s because that's what I put your graph as. And we're just going to keep doing that all the way up. And eventually what we're going to be able to do is just start connecting. So we're going to put a line, and this line is going to allow us to make some predictions as we go. Okay, so there's the line that would represent this data. Okay, if we want to predict, what the age would be, so like if we came all the way down to here, maybe like here, and say, well, when Carrie is 20, how old is Kim going to be? We could just trace this up and find out where that's going to be. Okay, but this is how we represent. And once you get about 4 points on there, you can go ahead and take a ruler and draw that line. That's good enough for me. Okay, well, we're going to stop there. And we got one last problem left. We're going to pick that up in class tomorrow. I want to work on that in groups as we go through. So if you have any other questions, hit up the webpage, Twitter, and discussion boards. We'll see you tomorrow. Have a good night.